Yes, today we discuss about that nucleophilic substitution reactions means replacement of one nucleophile by another nucleophile. Generally, replacement of this is nucleophile. Here we are taken generally alkyl halide with any nucleophile in the presence of solvent. So solvent, just here this is X nucleophile replaced by another nucleophile. This is we are calling as a nucleophilic substitution reactions. Just it is one nucleophile replaced by another nucleophile. This is we are calling as a nucleophilic substitution reaction. So here we are using the solvent is a different solvent we are using. One is a polar solvent, another one is non-polar solvent. If it is a polar solvent, we are using the polar solvent, what happen? If you are using the non-polar solvent, what happen? We'll discuss. Again, nucleophilic substitution reactions are two types. These are nucleophilic substitution reactions are two types. That is SN1, then SN2. Then another one is SNI. Three types are there. SN1 means unimolecular nucleophilic substitution reactions. It is a bimolecular nucleophilic substitution. This is intramolecular nucleophilic substitution. So here now we discuss about that SN1 reaction. This is very important reaction. So here now I will discuss first points, then after that we discuss about that all this mechanism with applications. So here we discuss about SN1 reaction. SN1 means unimolecular nucleophilic substitution reactions. Unimolecular nucleophilic substitution reactions. So in this case, first one, so I have to tell that what are the important points here. The first one, in this reaction to participate tertiary alkyl halides. In this case, to participate only tertiary alkyl halide. Then second point is this reaction forward by only polar solvents. Only polar solvents or polar protic solvent. Example, water, then acetic acid. These are the polar protic solvent. Then another one is here in this reaction that intermediate is carbocation. So here intermediate is carbocation. So again it is a two steps reaction. Again in this reaction, rearrangement and ring expansion also possible. So any reaction, carbocation as intermediate, then rearrangement and ring expansion also possible. Then final one is here final product is racemic mixture. So what is racemic mixture? We'll discuss later. Then here in this reaction used a weak nucleophile. If it is a strong nucleophile, weak nucleophile. If it is strong nucleophile, that is SN2. Then weak nucleophile, SN1. Again, rate of reaction depends on only tertiary alkyl halides. It is a first order reaction. So again, rate of reaction depends on only tertiary alkyl halides. It is a first order reaction. Now we'll discuss reaction R1 X with OH minus, then water as a solvent. In this case, so here this is a X replaced by OH group. One is a front side attacking, another possibility is a back side attacking. Two possibilities are there. Then first possibility R1 OH, then another possibility RC R double dash, then R. So here OH is right side. Generally we are calling as a D. We'll discuss later, that is in isomerism 50% D, then here 50% L. Both are same percentage, so we are calling as a racemic mixture. So I will tell you mechanism, how it is formed that reaction. I will tell you mechanism. So in this case, so I will write the mechanism here. This is actually two steps reaction, then step 1 and step 2. How it is formed that step 1 and step 2. Here step 1, first it formed the formation of intermediate or formation of carbocation. So here R1 R11 X, it is a polar solvent, so that is a soluble in polar solvent. It is a slow step, rate determining step. Always a slow step we consider as a rate determining step. Here which is more electronegativity, halogen, loss of X minus, then carbon get the positive charge. So here R1 R11, this is a carbocation, this is an intermediate carbocation. Here carbocation hybridization is sp2, then planar geometry. So whenever it is a planar geometry, the bond angle is 120 degrees. Bond angle is 120. Then step 2, formation of final product. The final product is a racemic mixture. So how it is involving the final product? Here this is a C plus, then R1, then R, then R11. Here attacking of OH minus nucleophile. So we are taking nucleophile. Here this is a fast step. So here either attacking of OH is a front side, one possibility. Attacking of OH is a back side, another possibility. Here first side, front side is a 50% possibility, and the back side also same possibility. That's what if it is a front side attacking, that is the first form. First, then R dash, R double dash. Then attacking of the back side, this is a O, C R dash, R double dash, O R. So it is a 50%. This is also 50%. So generally 50-50, that is a racemic mixture. So if it is these all are around that carbon, if it is R's are different, it gets the 100% racemic mixture. 100% racemic mixture. It is a purely depends on R group. So here generally they are asking the question in this SN1 reaction, reactivity order. So which is more reactive, which is less reactive, that is they ask the question. So here I will tell you reactivity order. So here that reactivity order of alkyl halides, reactivity order. So always tertiary alkyl halides are more than secondary alkyl halides than primary alkyl halides. Sometimes they will give the question that is a benzyl carbocation X, here OCH3, then here this is a CH2X NO2. So in this case it is a purely depends on stability of carbocation. If it is loss of X minus, then it gets the positive charge. Here loss of X minus, it gets the positive charge. So here carbocation which is directly attached to plus Me group, here which is attached to minus Me group. So here in the resonance, in the mesomeric effect, plus Me group increases stability of benzyl carbocation increases. So here which is more stable, then here this is, I will write here first and 2, then 1 is a more stable than 2. So here this one is a more reactive in SN1 reaction. So again tomorrow we discuss SN2. Thank you very much.